Welcome to the installation guidance video for the HESS-261-2h commercial and industrial energy storage system. This video will guide you step by step through the installation and commissioning of the HESS-261-2h energy storage system, ensuring safe, stable, and efficient operation. The HESS-261-2h is an all-in-one commercial and industrial energy storage system, integrating the battery system, power conversion system, local energy management system, liquid cooling system, and multiple safety protection modules. It is suitable for applications such as peak shaving and valley filling, demand management, and various C&I energy storage scenarios. This is the internal structure of HESS-261. When the indicator is green blinking or steady on, it indicates that the system is fault-free and the equipment is in standby, stop, or running status. When the indicator is red blinking or steady on, it indicates that the system has a fault or alarm and operation is not permitted. Before starting the installation, please read and fully understand the following safety statements. Please check that all items listed below are included in the package upon delivery. Here are the tools you need for installation. Mark the positions of the embedded anchor bolts on the foundation and secure the bolts at the marked positions using brackets or templates. Pour concrete and ensure that the anchor bolts are firmly bonded with the concrete. Use a forklift or crane to transport the energy storage system to the installation site and align it with the embedded anchor bolts. Secure the energy storage system using the M16 nuts provided in the accessories. Before performing any electrical connections, ensure that the equipment is fully de-energized and that all operations are carried out by qualified personnel. Before starting wiring, please confirm that the selected cable specifications comply with the system design and on-site conditions. Select an appropriate grounding method according to actual site conditions. Method 1. Ground the energy storage system through the PE grounding conductor. Method 2. Connect the PE grounding terminal of the energy storage system to the equipotential bonding device at the installation site or electrical room. The equipotential bonding device shall then be connected to earth, or the grounding grid. The grounding resistance must not exceed 4 ohms. Select a grounding cable with the cross-sectional area of at least 50 square millimeters. Use a wire stripper to remove an appropriate length of insulation from the cable. Slide a heat shrink tube onto the grounding cable, then insert the core wire into the OT terminal. Use a hydraulic crimper to crimp the OT terminal. Cover the crimped area with the heat shrink tube and apply heat using a heat gun to shrink the tube. Secure the grounding cable to the internal grounding copper busbar of the energy storage system using M10 combination screws. Connect the other end of the grounding cable directly to earth or the grounding grid, or connect it via an equipotential bonding device. Prepare the grounding cable and secure it to the grounding points of the energy storage system using M10 combination screws. Both the front and rear grounding points of the cabinet must be connected. Connect the other end of the grounding cable directly to earth or the grounding grid, or connect it via an equipotential bonding device. For flat ground bar grounding, secure the flat ground bar to the grounding points of the energy storage system using M10 combination screws. Both the front and rear grounding points must be connected. Connect the other end of the flat ground bar directly to earth or the grounding grid, or connect it via an equipotential bonding device. Ensure that the AC circuit breaker and the PCS DC load switch are in the off position to ensure safe operation. Ensure that all upstream and downstream grid side circuit breakers of the energy storage system are disconnected. Identify the R, S, and T phases of the AC connection cables and label them accordingly. Route the cables through the cable entry at the bottom of the cabinet. Perform wiring using M10 bolts, washers, flat washers, and M10 hex nuts. Confirm that all connections are correct and securely tightened. Before connecting the auxiliary power supply, ensure that the energy storage system is powered off and that grounding has been completed. The auxiliary power supply is connected via the XT1 connector. Complete the wiring according to the terminal markings. After wiring is completed, confirm that all terminals are securely connected, with no looseness or poor contact. When an external auxiliary power supply is used, the input power supply must comply with overvoltage category 2 requirements. Complete the wiring according to the terminal markings. X11 and X12 are external emergency stop signal terminals. If an external emergency stop is not connected, keep the terminals short-circuited. When an external emergency stop is connected, remove the shorting clip and perform wiring according to the project design requirements. When an internal switch is configured, these terminals are pre-connected. When no internal switch is configured, these terminals are reserved and no wiring is required. After wiring is completed, confirm that all terminals are securely connected, the A or B polarity of the communication cables is correct, and there is no looseness or poor contact. The network port adapter is used for switching the network connection of master and slave roles in a multi-cabinet system. Before connecting the network port adapter, ensure that the energy storage system is powered off and that the switch communication cables have been connected. When the energy storage system operates as the master unit, connect port 1 of the network port adapter to the local master switch using the parallel communication cable. When the energy storage system operates as the slave unit, connect port 1 of the network port adapter to the master unit switch using the parallel communication cable. Port 2 of the network port adapter is a reserved interface and is not used at present. After the connection is completed, confirm that the communication cables are securely plugged in, with no looseness or poor contact. Before installation, ensure that the AC circuit breaker and the PCS DC load switch are in the off position, and confirm that all upstream and downstream grid-side circuit breakers of the energy storage system are disconnected to ensure safe operation. Wear the required protective gloves and ensure that necessary protective measures are in place. Check that the MSD unit and accessories are complete, and ensure that there is no damage or missing parts. Open the MSD lever. Align the MSD with the battery pack interface and insert it to ensure that the mist is fully seated. Close the MSD lever and fasten the safety latch, and reconfirm that the MSD has no looseness or displacement. Complete the installation of the MSD for each energy storage battery pack by following the above steps. After the installation of the energy storage system is fully completed, a comprehensive inspection of the mechanical installation and electrical connections shall be carried out. Please check each item one by one according to the items listed in the table below, and make detailed records during the inspection process. If any items are found to be non-compliant, corrective actions shall be taken immediately. Before the trial operation, please perform the following checks. After completing the pre-operation checks, ensure that the energy storage system is fault-free and that operator protective measures are in place. Close the AC grid-side circuit breaker. Sequentially close the PCS DC load switch QS and the AC side main circuit breaker cuff of the energy storage system. At this time, the PCS power indicator will turn on. When using an external auxiliary power supply, rotate the switch SA handle to the left position, external, and then sequentially close cuff 1 cuff 5. When using an internal auxiliary power supply, rotate the switch SA handle to the right position, internal, and then sequentially close cuff 1 cuff 5. At this time, the explosion-proof fan performs a startup self-test, and the liquid cooling controller performs a startup self-test. Start the UPS by pressing and holding the UPS start button for 2 seconds. The UPS powers on and performs a self-test. After the self-test is completed, the UPS enters normal operating status. At this time, the switch power indicator lights up. The 4 grams router power indicator lights up. The indicator panel lights up. The EMS screen lights up. The water immersion transmitter indicator lights up, and the dehumidification device performs a startup self-test. If there is no abnormality in the above steps, the power on process is completed. Power off operations are generally divided into 2 scenarios: power off for normal maintenance or inspection, and power off due to faults or emergency situations. Perform the operation according to the actual situation as required. Sequentially disconnect the PCS DC load switch, the miniature circuit breakers cuff 1 cuff 5, and the AC side main circuit breaker cuff. Press and hold the UPS shutdown button for 2 seconds to turn off the UPS. Rotate the auxiliary power supply transfer switch SA handle to the middle off position. Open the AC circuit breaker. If the energy storage system is operating in external power supply mode, disconnect the external power supply. The energy storage system exits operation. Press the emergency stop button on the cabinet door. The energy storage system will stop operating and automatically disconnect the internal AC switch. After ensuring that the AC circuit breaker is in the off position, manually disconnect the PCS DC isolation switch. Turn off the miniature circuit breaker's cuff 1 cuff 5. Press and hold the UPS shutdown button for 2 seconds to turn off the UPS. Rotate the auxiliary power supply transfer switch SA handle to the middle off position. Disconnect the AC circuit breaker. If the energy storage system is operating in external power supply mode, disconnect the external power supply. The energy storage system exits operation. After troubleshooting is completed, rotate the emergency stop button to the right to reset. The AC auxiliary power supply of the energy storage system provides 2 power supply modes: external auxiliary power supply and internal main circuit power supply, which can be selected according to on-site requirements. Rotate the SA switch to the left, external position, and the equipment will be set to external auxiliary 220 volts power supply mode. Rotate the SA switch to the right, internal position, and the equipment will be set to internal main circuit 220 volts power supply mode. Rotate the SA switch to the middle, off position, and the auxiliary circuit will be disconnected. After confirming that all installations and electrical connections are correct and that the trial operation is successful, perform the following steps. Use the fireproof sealing putty supplied with the equipment to seal the PCS cable routing openings. Use the fireproof sealing putty supplied with the equipment to seal the power cable and communication cable routing openings at the bottom of the cabinet. Install the bottom protective plates. When the system consists of 2 energy storage systems, complete the communication cable connection via the switch. Before connecting the switch communication cables, ensure that both energy storage systems are powered off and that the auxiliary power supply and grounding connections have been completed. Use an Ethernet communication cable to connect the switches inside the 2 energy storage systems. The communication cable shall be inserted into the corresponding network ports of the switches in both cabinets, ensuring that the connections are fully seated.